Now today we will see about the biosynthesis of tryptophan and other aromatic amino acids. So we will see about the biosynthesis of tryptophan. This biosynthesis of tryptophan, as we know, the tryptophan is a aromatic amino acid contains an indole with a CH2 attached to CH, COOH and NH2. So this becomes our L-tryptophan. We have not shown the stereochemistry of this NH2 and COOH, otherwise it will become a L-tryptophan. It is always in a L stereochemistry. So this is our natural tryptophan. In this, it is this indole ring, and this part comes from serine when we are biosynthesizing tryptophan. This particular part will be coming from serine, while this part will be coming from chorismic acid, and these two carbons will be coming from ribose. The two carbons will be coming from ribose. This six-membered ring will be coming from chorismic acid. This nitrogen will be donated by L-glutamine. So there are four things that are being used here. One is chorismic acid, L-glutamine, ribose, and serine in order to biosynthesize this tryptophan. So we'll see first it will be from chorismic acid. Chorismic acid structure, we have seen it in our yesterday's lecture, that it will be here will be a dotted OH, and here we have an O with a phenol acid, and here we have a COOH group. So this becomes our chorismic acid. This chorismic acid undergoes reaction in presence of glutamine, so that this glutamine will be donating amine group to the chorismic acid. Glutamine structure is this is structure of glutamine, where it is a amide of glutamic acid. Amide of glutamic acid. So this amine group is donated, and here it will be hydrolysis of this amide bond will happen, and a glutamic acid will be generated over here, and this amine group will be attacking on this particular carbon, and there will be loss of hydroxyl group. Loss of hydroxyl group will result, so that we will have COOH. Here we will have NH2 dotted hydrogen, and here we have this group. Here there is a loss of OH group and a gain of amine is present. So now this will be resulting into aromatization via loss of pyruvic acid. Now this loss of pyruvic acid happens via When this bond comes, there will be this electron of this O carbon bond will be shifted towards this side, and there will be gain of proton here, so that we will get a CH3COCOH, that is pyruvic acid will be generated. So this pyruvic acid we can have it as after loss of pyruvic acid, we will have COH group over here, and here we will have a NH2, and other things all remains as it is. So we have got anthranilic acid here, and pyruvic acid is released. So pyruvic acid is released, and anthranilic acid we get it over here. So this anthranilic acid will be our starting point for the biosynthesis of tryptophan. Chorismic acid is first converted into anthranilic acid via amination by using L-glutamine, and loss of hydroxyl group will be giving us this that is beta amino acid. This beta amino acid here, this is alpha carbon, and this is beta carbon possessing amine group over here. Now this again undergoes aromatization reaction with the loss of pyruvic acid to give us a anthranilic acid. This anthranilic acid then undergoes complex reaction steps with the help of or by incorporating two carbons from ribose to form indole ring. It undergoes some complex reactions, and the first step of this will be reaction with ribose or ribosyl phosphate group. Here we will have a COH, and here as an NH2 will be reacting with let this be our pyrophosphate group. This will be fifth group OP, and here we will have OH, and here as an OH. So this becomes our ribose. Here the lone pair of electrons on anthranilic acid amine group, amine nitrogen will be attacking this carbon, and with the loss of pyrophosphate group, we will get this aromatic group. Along with here, COH retains its position. Now we have NH, then this 5-membered ring of ribose with a CH2 phosphate group. Hydroxyl groups on second and third carbons remains as it is. Now what happens is, in the next step, there will be the lone pair of electrons on nitrogen will be relayed to break this particular bond from the ribose. That is, ring opening of ribose will happen, and this we get as COH. Here we have an NH, double bond, C, H, then we have a C. Here we will have, so here we will have H and a dotted OH followed by a dotted OH with the H over here. Then we will have a CH wedge OH. This oxygen over here will be going in the opposite side than these two hydroxyl groups. Further, we have a CH2OP. This will be CH2OP. So this compound we will get. Now this compound then loses hydrogen, because here the nitrogen was having positive charge, so it loses this proton, and the electrons are relayed back to the nitrogen. So we get this as a COH. Here we have a NH, where it is now having double bond and hydroxyl group. Then we have a CH dotted OH followed by CH wedge OH and CH2 phosphate group. So this we will get. Now this compound, as it is having an enol group over here, it undergoes ketoenol tautomerism. What here it has undergone is a imine-enamine rearrangement reaction, or imine-enamine tautomerism. Imine-enamine tautomerization was happening over here. Here we had an imine, and here we have got a enamine. So in and amine. So from imine we have obtained enamine, but in that sense here we have also got a enol. So this enol will now undergo again tautomerism, but now it will be a ketoenol tautomerism. So this ketoenol tautomerism will now result into now ketoenol tautomerization will give us this will be our COOH. Here we will have a NH followed by carbonyl oxygen over here. Further, a dotted OH with a wedge OH followed by a phosphate group. Now this there will be a loss of carbon dioxide, that is decarboxylation happens. Now this decarboxylation results into generation of a carbanion here. That carbanion attacks this carbonyl carbon over here. So we will get this six-membered ring as it is, and we have a 1, 2, 3, 4 and 5-membered ring. This is 1, 2, 3, 4 and 5-membered ring we will form over here. So that will be this 5-membered ring we will get with a OH over here. Then we have a OH here followed by a wedge OH bond and a phosphate group. Here we have a H and H. Now it undergoes dehydration or aromatization reaction. will have an indole ring followed by this side chain containing phosphate. Now it undergoes a reverse aldol reaction where we will have breaking of this carbon-carbon bond from here, and so it undergoes a reverse aldol reaction. This was aromatization reaction or dehydration. Here, a reverse aldol will result into formation of indole, and this side it will be a glyceraldehyde phosphate. This will be 1, 2, 3 carbon glycerol and 3 trihydroxy 3 carbon compound, that will be glyceraldehyde 3 phosphate. We will get it CHO, that is this carbon now becomes a CHO group. Here will be having a CHOH, that is this one, and we will have a CH2OP. So it will be glyceraldehyde will be eliminated out, and we will get a indole. This indole moiety then reacts with L-serine, this is L-serine where dotted will be hydrogen. So this it reacts with L-serine. This lone pair of nitrogen plays an important role in this, and it comes over here, and this with the loss of hydroxyl group. And then again relay back, the aromatization happens, and we get a this will be NH2, and here we will have a COH2. This is nothing but the structure of L-tryptophan. So this is how we biosynthesize L-tryptophan from chorismic acid. थोड़ा सा लंबा है और थोड़ा याद रखना पड़ता है, कॉम्प्लेक्स है थोड़ा सा, पर्टिकुलरली जब हमारा राइबोस ग्रुप जब आता है तब वहां पे थोड़ी सी रिएक्शंस हमें बराबर से देखने पड़ते हैं. तो फर्स्ट स्टेप यहाँ पे क्या है कि आपका कोरिस्मिक एसिड में अमीनेशन होता है एंड विद द लॉस ऑफ हाइड्रोक्सिल ग्रुप. तो उसमें आपको मिलेगा एंथ्रानिलिक एसिड, एंड विद द लॉस ऑफ पायरुविक एसिड हमें एंथ्रानिलिक एसिड मिलेगा. ये आपका फर्स्ट स्टेप होता है. ये सिंपल रिएक्शन है, इसमें कोई ज्यादा डिफिकल्टीज नहीं है. बट इसके बाद वाला जो है कि एंथ्रानिलिक एसिड जो है, वो एंथ्रानिलिक एसिड नाउ रिएक्ट्स विद this anthranilic acid reacts with phosphoribosyl pyrophosphate और डाइफॉस्फेट. जब यहाँ पे दो फॉस्फेट ग्रुप एक साथ रहेंगे तो वी कॉल इट एज ए डाइफॉस्फेट और ए पायरोफॉस्फेट. सो इट इज ए phosphoribosyl pyrophosphate. So it reacts with this phosphoribosyl pyrophosphate with an elimination of this pyrophosphate group. So there will be a ring attachment. Now this A lone pair of electrons on nitrogen will be playing role in breaking this ribosyl ring, 5-membered ring of the ribose. That is, pyranose ring of the ribose will be furanose ring of the ribose will be broken. This then undergoes imine-enamine tautomerization. Imine-enamine tautomerization results into an enol. So it undergoes further ketoenol tautomerization. And this ketoenol tautomerization, upon decarboxylation on the ortho position to amine in the antranilic acid derivative, it will form a cyclization with a 5-membered ring fused to 6-membered aromatic ring. This undergoes dehydration or aromatization reaction to give a indole derivative, indole glyceraldehyde derivative. This undergoes reverse aldol reaction to give indole and glyceraldehyde. The indole then reacts with L-serine to give L-tryptophan.